OCR Statistics Bivariate Data 1 Scatter Diagrams. This is video 1.3, which is on using and interpreting scatter diagrams. Once you've decided on which axes the variables are going on and then plotted the points, you'll be able to recognize key features of the data. Firstly, outliers. An outlier in a bivariate distribution is a data point which deviates from the typical pattern to a notable extent. You'll need to be able to recognize outliers by eye. Let's look at some examples. In the first one here, we already have been given a line of best fit, so it's clear that the only outlier is here. The second one is trickier. I would say that these two and also these two are clearly outliers. You could also debate that this one could be one. For this one, I would say that this does not follow the pattern of the rest of the points, and nor does this. So these are clearly outliers. And again, you could debate whether this one was as well. This final one has much greater spread, so we can be a bit more lenient. I would say that this is certainly an outlier. And again, you could debate whether this one was as well. A scatter diagram is very useful for quickly checking whether a certain model is suitable. Let's look at the graphs again to see what this means. For which of the following is a linear model suitable? Well, in the first one here, we already have been given a line of best fit, so clearly a linear model is suitable. Here, if we ignore the outliers, you can see that generally the points do lie in a straight line, so we could use a linear model. Now, this one to me does not look linear. It looks more like the points are in a curved shape, and I would say that we couldn't use a linear model in this case. Now, for this one, even though there is a lot of variation and the points are in a cloud shape, they do generally follow a straight line. So it isn't so convincing, but I think a linear model could still be used in this case. This was video 1.3 on using and interpreting scatter diagrams, and the next video, 1.4, is on calculating Pearson's product moment correlation coefficient.